Hello and welcome to the webinar, Plastic Pollution in Lake Michigan, New Findings and Innovative Solutions, hosted by the Alliance for the Great Lakes. My name is Don Carr, and I'm the Alliance's Media Director. I'll be moderating today's webinar. In April, the Alliance for the Great Lakes released for the first time data collected by our Adopt a Beach volunteers, and the results are alarming. Over the past 20 years, our beach cleanups removed over 9,700,000 individual pieces of trash and over 535,000 pounds of litter from Great Lakes shorelines. 86% of that was either partially or totally composed of plastic. Our region is unique as we have challenges from pollution from plastic manufacturing and litter. So we thought it would be a good idea to hold a discussion focused on plastic pollution that impacts Lake Michigan as part of the current Chicago Water Week. And issues that cover this morning, Chicago Tribune by Adriana Perez. Fantastic story. I really hope everyone gets a chance to read that. So joining us today is Dr. Timothy Hoellein, Ph.D., Professor of Department of Biology, Loyola University of Chicago. I'll get that right. Dr. Charlyn Partridge, Ph.D., Associate Professor, Annis Water Resource Institute, Grand Valley State University, and Andrea Densham, Senior Policy Advisor, Alliance for the Great Lakes. So we'll kick it off with Dr. Timothy Hoellein, Ph.D. He's originally from Edinburgh, Pennsylvania. Tim Hoellein completed a BS in Biology from West Virginia, Wesleyan College, and a Ph.D. in Biology from the University of Notre Dame. He's a professor in Loyola University, Chicago's Department of Biology. Dr. Hoellein's research focuses on pollution in urban waterways, sources, fate, and biological interactions. Dr. Hoellein's goals are to continue to a greater understanding of aquatic ecosystems, incorporate students into research, and to support improvements by communicating results to other scientists, policymakers, and the public. Dr. Hoellein, please.
Right. Great, happy to be here. Hopefully you can see everything okay and hear me fine. I apologize if you've seen this before. I'd like to start with this picture. It's a cobra biting a python. The cobra is venomous, and as the python's dying, it strangled the cobra to death. Kind of an amazing picture of these snakes having this incredible interaction, especially if you like reptiles and predators. I saw this picture online, and this is how it actually appeared. That was a zoomed in version. So you can see the snakes have fought each other to the death and attracted, of course, lots of attention. But hopefully on the background, you can see that this is taking place in some sort of ditch or stream bed and is filled with trash. And I think it speaks to a kind of change in our experience of nature, where we've come to accept the kind of pervasive background abundance of trash and litter as part of our vision of how nature works. This is a friend who was working in a stream in Baltimore, studying the chemistry of the water, but you can see there's a problem here that's not just dissolved chemicals, but with trash. A lot of this work is in urban or human impacted ecosystems where we live, but of course this is a global problem. This is an island in the South Pacific that's uninhabited, but covered in trash because of the way that the ocean currents have distributed litter all over the world. When we study trash, or when you read about trash, we like to use the term trash, but you might also see it referred to as anthropogenic litter or marine debris. These are terms that really just mean anything that we've manufactured that gets out into the environment as litter. It can be all sorts of different kinds of materials like ceramics or glass or plastics, lots of different shapes and kind of physical properties. A lot of the trash that we find is plastic. And plastic itself is a term that encompasses lots of different kinds of materials, and many of which are composites of different chemicals. Plastic has a skeleton of a polymer, like polypropylene or polyethylene. Within that skeleton, there's chemicals that are added to give that finished product different properties. These additives are for colors or flexibility or heat resistance. And when we find plastic in the environment, we characterize it by size, by shape, by color, and its associations with other pollutants. You hear microplastics a lot. I think probably many of you know this. Microplastic refers to a particular size range of plastic litter. This plastic can be coming from many different sources. Some of them are nurdles or pre-production pellets, abrasives that are added to personal care or industrial soaps. And of course, plastic is changing in the environment. It can break apart and fragment, especially via the action of sunlight. And we have a lot of synthetic textiles in our clothing, our upholstery. And when a little thread breaks off of those textiles, that's a piece of plastic. And those fibers are very ubiquitous. in our environment. Plastic has all sorts of different kinds of effects. We, of course, think about these visceral images of animals that have eaten or been entangled in plastic. We know that there's unique microbes that live on those surfaces. This is a picture of a crayfish we found in a shoe in the Chicago River, so it's a habitat for some organisms. There's economic impacts through our stormwater management and tourism impacts. And then a way that we manage our waste in many post-industrial countries is to ship our trash overseas. And those folks that are employed to manage that waste are exposed to all sorts of hazards from our trash. The reason we're seeing a lot more trash and plastic in particular out in the environment is because we're making more. This is an estimate of plastic waste production from 1950 to 2015, separated by different kinds of economic sectors that it's used for. And you can see just about every year there's more plastic waste produced than the year before. So as part of the research I've been doing on trash, we've really focused on litter as a part of the environment to think about, how much is out there, where is it, what kinds, how is it moving, and how is it interacting with organisms. And the tools we use are really, a lot of scientific collaboration, of course, and student enterprises. But what's been really wonderful about this work is we can work with volunteers, that is community scientists or citizen scientists that are out there picking up trash already and writing down what they find. So I want to show you just a few results of some of the projects we've looked at citizen science or community scientists through beach cleanups, river cleanups, and a trash trap or seabin. Of course, the Alliance for the Great Lakes runs the incredible program, Adopt a Beach, and has been doing it for a long time. And this really rich data set has been critical to understand what kinds of trash we're finding in our Great Lakes beaches. I've had students do different projects, and this is one where a student looked at trash on some beaches in Illinois and New York. So a lot of stacked bars there. So if you just focus on one here, this is the amount of trash that the volunteers are finding on a beach in New York with the different categories or sources that we delineate in the data sheet. And to just give you a take-home point here, 75% of this trash is small, food-related or smoking-related trash. And by understanding those types, we can hopefully inform some solutions. Done the same kinds of projects with people who are out cleaning up the river. These are kayak programs run by Shit Aquarium, Urban Rivers, where volunteers get out there and pick up trash, write down what they find, and then we've been able to analyze their data. So this is trash picked up by kayakers in the North Branch of the Chicago River over a couple of years. Here divided by material type. And if I can, again, just summarize by looking at 1 year, it's the same trend. What we find is that 75 to 80% of the trash we find out there is plastic. We have it delineated as styrofoam or expanded polystyrene, which is plastic, and then non-EPS plastic, but consistent with the Great Lakes Beach volunteer data too. Finally, we've got the seabin. This is a trash trap that was recently installed in the right downtown in the Chicago River. It was purchased by Friends of the Chicago River and is operated by Wendella Cruise Lines. So they empty it once a week. We have students get down there and pick up the trash and sort through all the trash. This is what it looks like. We have just started this in September of last year. So this is what our trash looks like from the seabin over the period of last fall. Again, a stacked bar, but we just look at one for the same kind of pattern. The categories that we divide them into on our data sheet are here. And to give you a take-home point, 95% of this river trash is either small pieces, food-related trash, or smoking-related trash. So very similar trends to what we see on our beaches. The last item here on the graph is to look at that small trash category. This tiny stuff, less than 3 centimeters. Again, if we just look at one date here, it's the same pattern on the other dates. It's pretty evenly divided among these different proportions: fragments, foams, films, and pellets. And I want to highlight this pellets issue because this pellet is something we find throughout our beaches, throughout our river, and these are pre-production pellets or nurdles or virgin plastics that are used in the manufacturing of larger plastic items. Companies buy these in bulk, they melt them down into molds to create their products. But they escape. They escape in the transportation, in the operation of the plants, and we find them all over the environment, both in our region and elsewhere in the country and in the world. This is an image of one of our study sites in the North Branch of the Chicago River near Lake Forest, where we find thousands and thousands and thousands of these pellets. You can see them distributed here on the banks of the river. Here's another image with some idea of the scale of the amount of pellets that we see in this place. And when we look upstream, there's not a lot of stream upstream of this particular study site. And a quick search revealed 3 plastic manufacturing facilities. So it's not proof that these are the sources of those nurdles that we're finding, but it's just a few kilometers downstream, and it warrants certainly further investigation. And it helps contribute to a really growing collective body of work that suggests that new policies are needed for how these kinds of pollutants are managed and legislated. So to close here, as we learning from community science data, we can accept a few facts first. That litter is global in scope, it's increasing on the scale of our lifetimes, it's permanent. Litter has negative impacts on the environment, human health, economies, and those impacts are often distributed in unjust ways. And while we may not be throwing our trash on the ground, we are collectively responsible for this issue because we're collectively participants in the culture of its production, consumption, and disposal. With those facts accepted, we can move forward because as we measure what's there, where it is, and what kinds of trash are out there, we're better positioned to inform action and policy. And we can explore all the solutions that are possible, including the kind of materials innovations we need, changes in cultural norms and education, and of course, policy. And that this change is really doable. We've seen it work for some kinds of trash, so I'm sure it can work for others. And it works best when we're all welcomed and appreciative of contributions that are possible and keep up a spirit of sort of optimism, creativity, and really ultimately contributing to our communities. That's all I have. I'm happy to pass it on to the next speaker.
Thank you, Doctor. That was fantastic. Really appreciate that. I should say here that I'm sure so at the top, at the end of this, everyone's presentations will answer questions through the Q&A function. So please, if you have questions, throw them in the Q&A portion and we'll get to those at the end. Up next is Dr. Charlyn Partridge, Ph.D. She's an associate professor with Annis Water Resources Institute, Grand Valley State University. Dr. Partridge's lab focuses on using genetic and genomic tools to aid with conservation and natural resource management. Her current projects involve evaluating the effects of microplastic pollution on aquatic wildlife, developing and implementing molecular tools to detect invasive species, and understanding how invasive species alter the ecosystem they invade.
Great. Can everyone hear me? That's a classic Zoom question. So thank you. So I'm going to spend a little bit of time talking about the work that my lab has done, as well as other collaborators, looking at the interaction between microplastics and the microbiomes that they contain, and how those interactions impact the aquatic wildlife that consume them. Okay. So when we talk about microplastics we're not, and the impacts that they can have on aquatic wildlife, we're not just necessarily worried about the polymers that those microplastics are made of. Because when microplastics enter an aquatic environment, they develop what's called a biofilm. So this is a unique community of microbial organisms like bacteria, algae, and fungi that attach to the surface of those microplastics. And then because those polymers are also typically hydrophobic, they interact with other environmental contaminants that are also hydrophobic, which can adhere to the surface of those microplastics. So when aquatic wildlife consume microplastics, they're not just consuming those polymers, they're also consuming the associated biofilm, as well as any potential contaminants that are adhered to it. And it's that those unique communities and contaminants that have the potential to also move up and down the food chain. So kind of just to give you an indication of how pervasive these and how complex these communities are. So this is a study that was done, or part of a study that was done by one of my master's students, Maggie Peterson, looking and comparing the communities of the bacterial communities found on pristine microplastics. So these are those pellets that are from those manufacturing companies, so before they've kind of entered any type of aquatic environment, compared to what are known as weathered microplastics. So these are plastics that have been sitting in the environment for a certain period of time. And the pristine microplastics we found had 3 different bacteria families on them, whereas the weathered microplastics, so these were microplastics that were incubated in Muskegon Lake. This is a drowned river mouth lake that connects to Lake Michigan. And these microplastics were incubated for about 2 months within that lake. And after that 2-month period, we found over 900 different bacterial taxa present on those microplastics. And this is just a list of the top 33 families that we found on those microplastics. So during that weathering process, you are getting a really unique community of bacteria and microorganisms that kind of adhere to those plastics. And this is a graph showing the accumulation of other potential toxins that are also found in those environments. So this is a graph from Steinman et al. That incubated microplastics in that same Muskegon Lake. This is a previous graph. And they were looking at 3 different types of microplastics, so polyethylene, polypropylene, and polyester. And they incubated them at 3 different locations within the lake itself. And what they wanted to do, they wanted to compare in this graph the concentration of polyaromatic hydrocarbons or PAHs in those weathered microplastics compared to just the surrounding water, and then also those pristine microplastics. And when they were incubating those plastics near the bottom of the lake, they also compared them to the sediment. And so what this graph is showing is that those microplastics that were incubated from 1 to 3 months, you did start to see an accumulation of these PAHs on those microplastics. One thing to note, though, is at the lake bottom, the concentration of those PAHs was significantly less on the microplastics than when you compare it to the sediment. And then also overall, the concentrations are roughly 3 times lower than what's known as the probable effect concentration. So this is a concentration of PAH at which you should start to see negative impacts on biota. But we know that when these microplastics become weathered, they physically change due to the absorption of other contaminants and because of these microbial communities that are on them. So what could that potentially do to organisms that are consuming them? Because we do know that they are consuming them. So this was a study done by Muno et al. From 2022 that looked at the number of anthropogenic particles or plastic particles found in fish. And on the x-axis, we just have a couple of different fish species. If it has an S on the end, it's a shiner. BB is a brown bullhead, fathead minnows, round gobies, and then yellow perch. And so on average, they found that these fish contain roughly 52 microplastic particles within them. And that number can range anywhere between from 3 to 1 very poor brown bullhead that had over 900 plastic particles within its gut. So when they're consuming them, what are the health impacts on these aquatic wildlife? And the answer to that can be very complicated, and it very much depends. So this is a figure from a meta-analysis that was primarily concentrated on Great Lakes biota, looking at studies where they found microplastic impacts on the health of these Great Lakes biota versus studies where no effect was detected. So this was a meta-analysis of about 75 different studies looking at around 390 different endpoints, looking at all levels of biological organization, so from macromolecules all the way up to population assemblages. And the overall summary of this was that 60% of the time, when they were seeing if microplastics had some type of negative health impact, they found that it did roughly 60% of the time, but that means roughly 40% of the time there wasn't an impact of microplastics on their endpoint. So what this means is that the impact of microplastics is by no means universal. And what we really need is research to try to understand what's causing it when we do see impacts versus what is the mechanism when we don't see impacts. Part of this is because a lot of the studies where effects were detected were using concentrations of microplastics that were much higher than what you typically see in environmental conditions. One of the issues where you see impacts where no effect is detected is because they were using those pristine microplastics and not the weathered microplastics that have kind of more complex compositions. So for our lab, what we wanted to do is we wanted to see if we could see an impact of ingesting microplastics when we were looking at environmentally relevant concentrations of microplastics that were comparable to what we see in our area, but microplastics that were also weathered. So we conducted a study looking at the impacts of microplastic ingestion in fathead minnows. So we took 500 micron polyethylene beads, we weathered them in Muskegon Lake for 8 weeks. These were then embedded into food pellets, and we did a 28-day feeding exposure period. All of the fish were kept in flow-through systems, so they were housed in Muskegon Lake water, and this was the same water in which the microplastics were incubated in. And then the fish were fed 16 food pellets per fish per day. We had 3 different treatments. So we had a control group where they only received the fish pellet food and no microplastics, a low treatment group where they consumed 4 pellets with microplastics and then 12 pellets without microplastics, and then a high treatment group where they consumed 16 pellets that all contained microplastics. And this is kind of what our little food pellet looked like. So here's the food pellet, and you can see kind of that blue polyethylene bead embedded in it. So what did we find? These are just showing 2 endpoints that we looked at. So we looked at growth over that 28-day exposure period, and then we looked at condition factor, which is kind of a measure of fish robustness. So it's kind of looking at a standardized ratio of fish weight to length. And so what we found is that in females, there was no significant impact of a microplastic treatment. So females didn't have any differences in overall growth over the course of the 28 days, but we did see a negative impact on males. So males in our high treatment had lower overall growth than males in our control group. And then for condition factor, we saw kind of a similar pattern with no impact in females, but we saw a downward trend in condition factor, although this was not statistically significant. So things like these sex effects may be contributing to some of that variation that we're seeing in kind of the overall literature, where some studies are showing impacts whereas other studies aren't. And this just kind of goes on to kind of support the fact that we really need more research kind of looking into these health effects and the mechanisms driving them. And so what does this mean in terms of overall context? So this is a figure from Burns et al. Looking at what concentrations are needed in terms of microplastics to have negative health effects. And this image, or this kind of curve on the left, this green curve, indicates the environmentally relevant concentrations that you typically see of microplastics in the environment. And the red is the distribution of microplastics concentrations that are typically needed for you to see negative health effects across a host of different organisms. And from this graph, they concluded that because there's such a large gap between the concentration of microplastics that drives negative health effects and the concentration of microplastics we typically see in the environment, they suggested that this means that microplastics aren't really something that we need to worry about in terms of wildlife health. However, when we put our study in this context, so we saw negative health effects of male fathead minnows with only 1.6 particles per liter, shifting this effects curve closer to that environmental relevance curve. So what this means is, I think as we conduct more and more studies, looking at specifically weathered microplastic impacts on overall health, we're going to start to see this curve shift more toward the environmental concentrations, and that will kind of give us a better indication of the overall impact microplastics will have on these wildlife over time. And that's what I have.
Thank you, Dr. Partridge. That was fantastic. Coming up next here, Andrea Densham, Senior Policy Advisor, Alliance for the Great Lakes. Andrea serves as our Senior Policy Advisor at the Alliance for the Great Lakes, working to advance sustainable environmental policy across the Great Lakes Basin. Andrea is an environmental Great Lakes policy expert with over 2.5 decades of experience working with government leaders across the Great Lakes Basin and in state capitals, Congress, and binationally. Andrea also successfully advocated for coastal restoration and climate solutions in the Great Lakes, designed and established innovative programs, regulations, and research at the National Oceanic and Atmospheric Administration, Fish and Wildlife Service. She's also advanced public health initiatives with the National Institute of Health and the U.S. Department of Health and Human Services. Andrea earned her master's in political science from the University of Chicago and has lectured at numerous universities across the region. Andrea, please take it away.
There we go. In trying to be so ready for the other part, I muted myself. Thank you for great context from our two researchers. I'm going to try to go through this quickly so we have some time for the great questions that I'm seeing emerge. What you really got a really clear state from both of our researchers is that plastic is clearly a threat and a concern for all of us in the Great Lakes. You heard mostly about the pollution that's happening from litter and the impacts on ecosystems. And I'm going to talk a little bit about some emerging issues around human health, and then what our policy solutions might be. And then we can have a good dialogue, I hope, with the last few minutes that we have left. But it's really clear that the plastics are impacting substantial amounts of ecosystems, that our Great Lakes Basin is rich and vibrant, and is also the home of many endangered and threatened species. So the impact, for example, that we were just discussing on potential reproductive impacts on especially endangered and threatened species would be especially important for us to think about. It's also important for us to think about our drinking water. Many of us, I live in Evanston, Illinois, get my drinking water from Lake Michigan. It matters what the concentrations are in the lake. And it really matters that we're thinking hard about coming up with smart and impactful solutions. One of the things that's super unique about the Great Lakes region, and is quite different from our friends on the coast, except for our friends at the end of the Mississippi River down in the Gulf of Mexico, is that we are both the site of production of plastic and the litter that is a result of it. That means that we need solutions here in our region that address both how we produce the packaging and materials and what we do at the end, as well as across the life cycle. You know, it's really one of the things that we began to have a dialogue about here are pre-production pellets. And I think we often think about plastic, we think about the end product, especially in the packaging space, but we don't think as much about what makes plastic. And plastic is a combination of petroleum plus toxic chemicals. Some of those are especially toxic, and they're known toxins. Those are put together in those production pellets and with some additives. And it's in that process that we need to think a lot more thoughtfully in our region about some smart upstream solutions that move us away from the worst of the worst and the most polluting impacts. We also want to really make sure that we're protecting public health, our drinking water, and clearly our ecosystems. The chart on the right really gives you a sense of the whole spectrum of impacts, from production all the way to the end of life in our waterways. We have many solutions to address these things. And then one of the other things I want all of us to think about and understand, and I think Tim got to this, is that all and each one of us has a role. Innovators and businesses, funders, the public, all levels of the public sector, from state, federal, municipal, and binational, and clearly researchers. We have some information, but we need much more information. And you'll hear me talk a little bit more about how important it is going to be for us to have longitudinal data moving forward. When we think about policy solutions, there's a couple big buckets that we like to think about. One really critically important one is protecting human health and aquatic ecosystems. You heard a little bit in one of the presentations from our researchers about the impacts, the growing knowledge about the impacts on our ecosystems. We also have a growing bit of knowledge in terms of human health. We need to be really thoughtful about regulating and increasing regulations of harmful plastic chemicals. We need to have ongoing longitudinal water monitoring and enforcement. We need prevention that stops the pollution at the source. We need to get rid of the worst, like foam and plastic bags. We need really to move to redesign. I do want to take just a minute to talk about the really rapidly increasing body of knowledge globally that's happening, but also here in the Great Lakes region on the impacts of plastic on public health. This is a UNEP report from 2023, but just in the past 6 months in 2024, we've seen a whole new set of studies. One of those studies was discussing the impact of microplastic and nanoplastics on cardiac health, with potential impacts on cardiac disease and diabetes. There's also this fairly recent study that also talks, and as an old public health person that worked on public health systems, this one caught my eye. And I think it's really important to think about why preventing at the source, at the beginning, can actually not only be good for human health, but it can be good for saving money. This study identified that the chemicals in plastics, the cost for the health impacts reach around $250 billion in 2018. That means those chemicals used in the production, and again, those of us in the Great Lakes are going to experience more of the byproducts, both in the air and the water, of the pollution that happens when making it. That's a really significant issue, and it's one that's important for all of us to keep in mind as we move forward. The last thing I just want to talk on when we're talking about the data that we have and what we know right now, and that data really is emerging quickly, is that plastics and chemicals are really part, and the way in which they're constructed and made and manufactured really have an impact on climate. In fact, if we are able to eliminate 1 million tons of plastics from production, we'd be able to reduce 3 to 5 million tons of CO2. So we don't often think about plastic production as contributing to climate change, but it absolutely does, because it is petroleum plus toxic chemicals that make it. So we really, as we've been moving forward, not only in the Great Lakes region, but also globally, as INC4, the global treaty negotiations, just wrapped up a couple weeks in Ottawa, we're seeing real movement in these discussions about banning and regulating harmful plastics, about increasing transparency about what kind of plastic chemicals are used in the packaging, so that actually researchers and public health folks can have a better sense of that, and really beginning to move towards extended producer responsibility. So, as I discussed earlier, there are a couple core buckets and ways that we can move forward with this. And when we talk about policy solutions, I try to remind everyone that laws are one tool in our toolbox, administrative rules and regulations are another tool in our toolbox, and procurement and purchasing is the third one. And if we think about what kinds of solutions we need to be moving forward, there are 3 buckets. One is production. How do we reduce at the source? How do we invest in innovation and sustainable manufacturing? How do we reduce the amount of the use of chemicals of concern and increase the amount of recycled content? And in terms of the reuse and the use side of this, how do we move towards reuse and repair? And how do we do things like we did in the state of Illinois by increasing the amount of water refilling stations we have? And disposal, we absolutely need to begin to invest in smart municipal recycling and composting. It's a both and approach, and we need to be starting to put money behind that. The other thing I just want to note really quickly, and I'll be wrapping up soon so that we can begin to have a dialogue together, but we in the Great Lakes have the opportunity to do really interesting and unique things. And there's beginning to be a much more coordination between states. There's dialogues much more between what's happening in different states and a discussion binationally. So one of the things that I urge everyone here, no matter what role you play, whether you're monitoring water or you're innovating new solutions, or if you're a regulator, is to think about how we can talk more and work more together. So one core piece is that we really need to think more about extended producer responsibility regulations. We really do need to look at regulations of toxic chemicals and investment. And the last thing is, in addition to the kind of research you heard from today, we also need more research in human health. And we need to support not only federal EPA, but also state-based EPA in tracking and monitoring our drinking water and pollutants. So as I just noted, there was a great opportunity for us to have this dialogue in the Great Lakes region, in Ottawa, at INC4. I just wanted to make a note that our Great Lakes mayors and the mayors on the Mississippi River Basin got together and said, we believe that together we must work to find smart solutions. And remember, the mayors are at the tip of the sword of this. They're the ones who are dealing with it every single day. They came up with a really smart set of suggestions, and hopefully we can develop that similar sort of smart suggestions that we start to implement, not only across the Great Lakes Basin in the United States, but binationally. And there are wins. As hard and as challenging as this is, we're seeing wins. We saw wins just last year here in the state of Illinois. We're seeing wins and work happening across the basin. We are able to get a refill and reuse bill passed, meaning that we can bring our own containers in to be refilled, which is a really important first step. We're able to move forward with the state, ensuring that they're changing their procurement laws and what they're buying, which meant that we've already seen a reduction in styrofoam and foam purchased by the state of Illinois, which moves marketplaces. We're seeing really good and important work on monitoring drinking water and the water refill stations we just talked about. And most importantly is systemic work that moves us upstream, that says to producers, you get a choice on how you build something and how it's manufactured. And the type of laws that help us with that are called extended producer responsibility. Right now in Minnesota, they're negotiating a bill. It's 2/3 of the way through the process. In Michigan, our friends in Michigan are beginning the drafting of a bill. And here in the state of Illinois, we're able to pass a needs assessment bill, which means that the Illinois EPA is beginning the process of learning more about how we should build an extended producer responsibility system in our state. This is the type of solutions we need that move upstream, that change the type of packaging, that reduce the amount of single-use plastic at the source, and also reduce the amount of toxic chemicals in it, and also build jobs and local economies, and really help out local municipalities who have to deal with the burden of our recycling process. I just wanted two quick things, a couple more things, but one, I just wanted to talk about plastic pellets. It is the piece that's used in the production of the plastic at the end of life, whether it's packaging or other things. And remember, packaging isn't just for consumer packaging, it's also for commercial use. Someone asked a question about Senator Durbin's bill. That is absolutely in the process in Congress. But we are also seeing our colleagues in Michigan going to be introducing a bill this year in Michigan. And I think that shows the interplay between the federal level and the state level. And we need much more of that coordinated work. Those pellets need to be controlled. They need to be managed and monitored. If the pellets that Tim illustrated was an oil spill, we absolutely would have folks out there cleaning it up. But this has sort of made its way through, and it's not being regulated at the same level. So this plastic pellets bill and the one the state of Michigan is going to be moving this year really hold producers' responsibility just to contain the materials, a pretty reasonable expectation. We also, and many of you might have seen the recent media on this, we're working here in the state of Illinois on a microfiber bill. It just says that we should be having filters in washing machines. You know, what we know right now that And as a bit was described by Tim, that microfibers, which have plastic and synthetics in them, is really growing and exploding. In fact, there are 18 million microfibers in a single load of laundry. That's a lot. Well, we can keep it from getting into our sewer systems and into our waterways by having filters in our washing machines. It's a simple, easy preventative solution that will save money downstream, protect our public health. We're really hopeful that we can move this forward. We can encourage manufacturers to make those in our state, and that we can get other solutions like this that go upstream and produce more sustainable, less toxic products moving forward. And just two more things, and then I'll be done. And one is that we're really working hard in our state and have in many other states on reducing the worst of the worst pollution. So foam and plastic bags, we're going to work very hard, and we are working very hard right now. And we encourage all the public to contact their elected officials to urge them to support bills that reduce the worst of the worst foam and plastic bags. We don't need them. Our other states have been doing this in municipalities and seen great success. And the other thing to note is that it really does a number on municipal waste systems, and it costs them much money to deal with the non-recyclable foam and the plastic bags, which gum up their system. Redesigns like this are smart, and we should be moving forward. Not only does it reduce the amount of single-use plastic water bottles, but it increases access to drinking water for many. And water monitoring is critically important. As you heard from the researchers, we need much more monitoring and data collection, and we need it over time. So thank you so much for the time, and hopefully we can get to some of your questions. Thank you again.
Thank you, Andrea. Excellent as always. Start off with the Q&A here. Ellen asks, does food related mean packaging, etc.? I assume it does not mean biodegradable food. Ellen, I believe you are correct there. I think I can answer this one. We're talking about food packaging when we talk about that. The next question, I think this is for Dr. Hoellein. Sea-bin basically looks like the same concept as a pool filter. Any reason why it hasn't been more widely adopted by cities with water resources? Oh, we're gonna let Andrea take that one.
Say that again. I'm so sorry. Can you repeat the question? I'm sorry.
It disappeared on me. Hold on, went to the bottom. They got reordered here is what happened, I think.
Okay. So sorry.
This is strange. All right, let's see. How about we give this one to you, Andrea, from Matt. Can the last speaker discuss consumer knowledge and consumer choice behavior and how important that may be to complement the policy and legislative tools in the toolbox?
You know, I think one of the interesting things in the sphere around plastic policy is that we have really pushed decision-making and changing marketplaces onto the consumer. One of the reasons why we care so much about extended producer responsibility bills is that the choice of how something is made and what the materials are that are used in that, including some of the toxic ones, is the choice of the manufacturer. It is really important for consumers to engage in their civic process. Making choices to move towards reuse is always fantastic and wonderful, but we also need to ask the manufacturers and really require them to move towards reducing at the source the amount of plastic they make, and really being thoughtful about what kind of materials they use in the packaging they create. And again, this is not only for consumers, but also on the commercial side. And one of the reasons why I brought up procurement or the purchasing of things at the governmental level is the order of magnitude of impact in terms of moving markets is even bigger when the federal government, a state government, or a city government moves those things. It's also similarly really important when a really large player like a baseball stadium changes what they're buying and moves in a different direction. I love it when consumers move in the right direction. I love it even more when you reach out to your elected officials and ask our manufacturers to make smarter choices.
Okay, here's a good question from Dr. Hoellein. Is it possible to estimate the amount of plastics in the Great Lakes that are not easily measurable? For example, sunken or heavy plastics?
If the question is, can we actually get down there and measure them? The answer is not really. It's very challenging to measure things at depth, and especially across such a large area. So the estimates in terms of total loadings of plastic to the Great Lakes have been done by kind of modeling how much litter escapes our waste management systems, and some of the measurements of microplastic that have been done to the the tributaries that enter the Great Lakes. So it's a system of combining kind of big picture metrics of waste management with on-the-ground measurements of tributary input to try to put together a budget or a picture of where all the trash may be. But those deep water ones present a real challenge, both in the Great Lakes and in the oceans.
Thank you. Dr. Partridge, I think I have a good one for you. Is the microbial community that adheres to plastics different than those that presumably grow on small pebbles, natural organic material, etc.? From Matt.
Yes, so it appears that the chemistry of the plastic itself really has a strong influence on the microbial groups that grow there. So they are different than what you would find just in the natural system, but also like polyethylene microbial communities are different than what would grow on like PVC or polypropylene. So that polymer really drives kind of what is attaching to those plastics.
Okay, this next one, thank you for that, Dr. Partridge. This next one, I'm gonna kick over to Andrea again. Marion is asking, how heavy a lift will be to get plastic pellets registered as hazardous and added to the Clean Water Act?
Yeah, I think that's a really important part of the discussion. I think what toxins we identify and how we insert them into the Clean Water Act and have increased monitoring of them is really important. I think the plastic pellet bills that we currently have are an important first step, but there are additional steps. And I think the reasons why I hit and discuss toxic chemicals as many times as I have is I really want this community to begin thinking about how we can begin to monitor and regulate those that are especially known toxins, and begin to expose and have better understanding of the amount of toxins that are used in the production of plastic, so that we can better monitor what that looks like either in our drinking water or in the aquatic world. But we absolutely need to begin to think about, just as we have around PFAS, because PFAS-like chemicals are sometimes used in the construction of, and at least they were in the past, in the construction of some plastic materials. We need to begin to have a better understanding and really regulate those that are known, especially dangerous toxins.
Thank you, Andrea. We're getting a lot of questions on recycling of plastics, viability, should be looking at plastic recycling. I'm gonna throw it out to the group. Does anyone want to tackle that one?
I'll grab it. So it's recycling is a tool in the toolbox, right? The reason why you heard me talk so much about changing how we make things is different materials are more easily or less easily recycled. And at this point, our recyclability of plastic right now is really low, like approximately 8%. It is extremely low, definitely below 10, and it really depends on state and where you're at. Moving away from single-use plastic, moving towards reuse and using other materials that are less toxic is absolutely important. That said, there is already a lot of plastic in our marketplace and in our environment, and we need to, for where there is plastic made, we need to make sure that there's a recyclable marketplace and that it's made out of 100% recyclable, and that the system of recyclability is improved, and that we remove the worst of the worst pieces that actually gum up the system, which is why I was talking about foam and plastic bags as things we simply need to eliminate. They have been eliminated in the EU, Canada, and all over the place, and in states and cities across the country. So recycling needs an investment. I think we also need an investment in compost across the state of Illinois and across the Great Lakes Basin. These things are all part of a whole, but not one of them alone is going to solve the problem.
Thank you for that. I think I've got one here for Dr. Partridge, but if Dr. Hoellein wants to jump in this as well. Arthur's asking to talk about the challenges to collect samples and test for microplastics. What are the challenges with that?
Yeah, I can start, and then if Tim wants to add, I think, I mean, part of the challenges we see is kind of size distribution. So a lot of how much are you actually, so when you're collecting these microplastics and the ways that we at NS kind of collect them may bias our collection toward larger microplastic particles and kind of not get a really good feel as to the number and prevalence of nano microplastic particles, which kind of can also have a significant impact on the wildlife through like embedding in tissues and in the gills of fish. So I think that's kind of like the biggest challenge for us is the fact that many of our sampling techniques may bias towards those larger particles and miss kind of those fine plastic particles that are also having a significant impact.
Yeah, I agree. It's very tedious and challenging to measure microplastics because they're well colonized by microbes. So you have to separate it from the natural organic material, isolate them onto filters. We use a kind of visual search medium as our first pass on microplastics, which involves, students under microscopes counting particles. And then we do a polymer identification process, one particle at a time, by transferring those to a separate microscope. So the person power required is really pretty tremendous to get a strong data set.
Great. And Dr. Hoellein, this is again for you. Angela says she kayaks regularly on the north branch of the river. Can you tell us how we get involved in collecting data, et cetera, on the river for you?
Yeah, sure. I mean, the group we're working with right now is called Urban Rivers. They have a program called River Rangers. They do a really amazing job of working on river restoration through these floating wetlands and then engaging volunteers for maintaining wetlands, counting pollinators and birds, and picking up trash. So they have a pretty robust system in place to work with volunteers and manage the volunteers' data. And they do that throughout the Chicago River. So I'd suggest first looking at Urban Rivers. You can Google that, and their program is called River Rangers. But for people who want to volunteer sort of anywhere, there's a number of apps for your phone that you can use. For example, NOAA Marine Debris Tracker is a downloadable app that you can write down what you find and submit it to the cloud and the data set that's emerging. So NOAA Marine Debris Tracker is a good one. River Rangers if you're in Chicago. And then, of course, the Alliance for the Great Lakes has tons of beach cleanups if you're elsewhere and want to contribute. You can sign up online and submit your own data from your cleanup.
Thank you, Doctor, and appreciate the shout out for our beach cleanup. Andrea, this one's for you, I think. Has implementing a plastic bag tax had a positive impact on decreasing the amount of environmental plastic bag waste in the region?
So one of the most impactful ways to reduce the amount of plastic bags in the environment are bans. The tax component has differing impacts depending on how the public policy is constructed. And each one, and this is sort of, you hear me talk about moving stepwise. So it has an impact. Bans have an even higher impact of reducing them out. It is also important to note that bans also don't only impact them in the environment, but as I was talking about, it's also production. So there's less of them produced. So that same is true when we're thinking about foam. If there's less of it being bought, then there's less of it being made. And this is a great opportunity for me to talk about, which I failed to do earlier, so my apologies, but those who live in and work near those factories are experiencing a disproportionate harm and a concentration of the pollution from the production of the plastic. And so the more we can remove the worst of the worst plastics, not only is it reducing the amount we're seeing in the environment, it's also reducing the harm that's happening to those that live in and work near those communities, but near those manufacturing sites.
Great. Thank you for that. I think we have time for one more question. There's been a couple questions in the chat about this, so I'm just going to throw out to you guys, and probably Andrea will be the first one to be able to kind of address this. But a lot of questions about compostable products and the viability of compostable products and where they fit into this problem.
Does either of the other researchers want to jump in? I'm happy to say my 2 cents. Okay. how something is made and what the components are really, really important. You saw that one of the elements that the mayors talked about was transparency in what the materials are and the subcomponents are of the packaging. Compostability matter. If things are truly compostable and there's not toxic additives in it, then there may be some benefits. However, we've had some challenges with some of the pieces being marketed as compostable when in fact they have either some plastic components in it or some toxic chemicals. I think this is why the packaging side on compostables needs to be regulated more. There needs to be clearer rules around it. There needs to be rules around transparency about what's in it. And we need to ensure that the worst of the worst toxic chemicals are not used in the creation of them. I think there's more learning to be done there. I will also say that I think there are some ways in which we could use byproducts from our agricultural systems here in the Great Lakes Basin without using toxic chemicals to build things like boxes and other materials that might be really useful and reduce the amount of dependence on single-use plastic.
Excellent. Thank you very much. And for that, I think we're done. Fantastic job, everyone. Really appreciate Dr. Partridge, Dr. Hoellein, Andrea. Thanks for doing this. Big thanks to the current Water Week for hosting this event and promoting it for us. And thanks to everyone for joining. There'll be a follow-up email with a link to the recording of this. And with that, we're going to end. Thanks, everyone.